Network cabling transmission media started in the 1970s and 80s with the coaxial cable, also known as coax, COAX. It was a popular networking cable type used during that time, but it quickly declined in the 1990s and by the 2000s it was hardly in use. However, today you may still see some use of the coaxial cable as an audio-visual connection cable, such as between an over-the-air antenna and your television, or from your wall to your cable modem. Now, let's get technical. The coaxial cable has a center core of copper wire surrounded by a layer of insulation, which in turn is surrounded by conductive braided shielding and encased in a final insulation sheath. Key note: the center copper core and the braided shielding layer act as two independent conductors, allowing two-way communications over a coaxial cable. Plus, all this shielding makes a coaxial cable fairly resistant to electromagnetic interference (EMI), which was important in those days because it allowed higher bandwidths in comparison to other technologies of that time period. Now, let's deeper dive into the technicalities. There are two types of coaxial cable, the first being thicknet 10 base 5 and the second being thinnet 10 base 2. Each have their own distance spans in meters shown on the screen and their own throughput known as the speeds. In those days it was megabits per second, Mbps rather than gigabits. Oh yeah. Key CISSP exam tip: it's all about the base. Simply put, the base represents the distance span of the wire, meaning a base 5 means 500 meters before the coaxial cable runs into problems with signaling. Okay, so now we understand the fundamental concepts of coaxial cables. So what were the problems? Well, the most common problem was bending the coaxial cable past its maximum arc radius, aka bend point, and thus breaking the center copper metal conductor. The other problems lied in deploying the coaxial cable in a length greater than its maximum recommended length, e.g., 500 meters for 10 base 5, but no more than that. The other problems lied in terminating the ends of the coaxial cable. All these problems led to the coaxial cable ultimately failing to retain its place as a popular networking cable of the time and was quickly replaced with a new alternative. But what was that? Well, let's fast forward a decade or so to the 1990s, where a cheaper and more convenient alternative arose on the market, and this was known as the twisted pair cabling, which was also extremely thin and flexible compared to the coaxial cable. Very important technical caveat, not in many textbooks. The coaxial cables are able to transmit over 80 times the amount of data of a twisted pair cable. This is why coaxial cables are almost always used for high-speed communications, including internet, cable, and telecommunications services. Now, back to twisted pair cabling, which actually consists of four sets of twisted pair combinations, as you can see from the different colored wires, which makes 8 wires in total. That's 8 wires into one big wire. Now let's deeper dive into the technicalities, as there are two types of twisted pair cabling, and the key differentiator is a key CISSP exam note, being remember foil. Yes, FOIL, which is what you wrap your sandwiches in, which basically is a layer that is included in one of the types of twisted pair cabling, explained in a moment. You see, the first type of twisted pair cabling is known as UTP, unshielded twisted pair, aka no foil protection, whereas the second type is known as STP, shielded twisted pair, which has a foil protection layer, which provides additional protection from external EMI. Now, you may be wondering, well, why are the cables twisted? Good question. Well, the answer is quite simple. The twisting of the wires provides protection from external radio frequencies and electronic and magnetic interferences, and also reduces crosstalk between the twisted pairs. Key CISSP exam note: not all twists are equal, meaning each twist is twisted at different angles, which means different rates. Meaning, generally, the tighter the twist, the more twists per foot, means the more resistant the cable is to internal and external interference. And this improves the overall bandwidth and speed of the cable. So there are several classes of cabling types under these two categories. So let's start with the UTP cabling category types, of which there are 8 UTP categories with their own throughput rates. Generally, the minimum category is 5E, and this goes down to Cat 8, which is the more expensive and modern. And for completion purposes, UTP cables use end connectors known as RJ45s. Ignore the zero typo on the screen. And this same RJ45 end connector is used for STP twisted pair cables. However, STP cables are more difficult to terminate. So, for absolute clarity, the RJ45 end connector looks like this, which is what is in your computer and many of your home devices, especially those directly connected to your router using a Ethernet cable. Most likely a Cat 5e or maybe 6. Now, I want to draw your attention to some important technical limitations, which is more a physics lesson on conductors and copper and electricity. Both coaxial and twisted pair cables use copper as the most popular conductor for its center core, but copper has some distance limitations, which makes electron flow resistant the longer the cable becomes, and this degrades the signal strength and quality of the signal over the length of the cable. This concept is known as attenuation, which you can Google for more scientific explanations. But for the context of the CISSP exam, just remember shorter cable lengths increase the speed of transmission. To visualize this, let's imagine the original electronic signal going through the wire, and the problem when the cable becomes longer. This original signal actually becomes weaker, known as attenuation. But this can be fixed through a process known as amplification using a repeater or concentrator device, which simply put amplifies the electronic signal over the copper wire, expanding longer distances. So those were conductor-based network cabling. However, there is a new modern technology known as fiber optic cabling, which is the pioneering technology of the current modern day, and you may already be on it, or you may be getting letters to go onto it from your internet service providers. Fiber optic cables transmit pulses of light rather than electricity through shards of small glass within the cabling type. The use of light signals make fiber optic cabling extremely fast and impervious to any tapping or electronic interference, unlike the cabling types. However, there are some disadvantages to fiber optic cabling, which vary from cost and availability in your area. As for the category types of fiber optic, there are two deployment modes, known as single mode fiber and multi-mode fiber, of which each has its pros and cons as seen on the screen with these bonus tips. And each mode generally has a dedicated color as seen on the screen. And to recap, here are the cabling types discussed throughout this video. Thank you for watching today's video. I hope you enjoyed the content as much as I enjoyed creating it. If you would like to see more content like this, it would be super fantastic if you could leave a like and subscribe to help support this channel's growth.